measures the center that we want to look at, and that's the mode. And the mode is the most frequently occurring observation. So if you've got your data sorted, what is our mode?
76 and 82.
What is it?
76 and 82.
76 and 82. And I think that's, they occur 3 times? So that the mode is, now again, I guess the same question, you know, we got these other 2 measures, statistics, okay? The mean and the median, and the mode, who cares about the mode? Why even report the mode? I mean, these other 2 give you a lot of information, right? That kind of,
Is there only 282s?
I think there's 3. Oh, I got 3 here.
I wasn't looking in the calculator.
Okay.
Just guessing, like if you have 2 big spikes on one at 2 different points, then it would be good to know that like the large representation is occurring within those spikes.
Absolutely. Remember the graphs I gave you the first day, and I said, what does this describe? Anybody remember we did that little drill, and I said, what does your graph describe? But one of them, you know, I said it was a 5-point scale, and I think I drew the graph something like this. And I said, what does that typically represent? And you guys were pretty sharp. You see a lot of that type of data when you ask people their opinions. In real life, I mean, that is what you see a lot. And that, I was kidding before, and I'll kid again, but that's because if you go to a restaurant and you get a 5-point rating scale from, you know, I don't know, very unsatisfied to very satisfied, there just ain't a lot of people who say, before I pay the bill, I gotta take 5 minutes and tell these people how average they were. They just don't stop and do that. People just don't stop and say, Sonia, I really love you. You are the most average person I know. And people don't do that, right? What they do is they say, you guys are absolutely horrible. This is the worst place I've ever been to, okay? Those are the people who fill out these cards, these kind of attitudinal cards. These people over here says, you know, you're great, absolutely terrific. And so you see a lot of what we call bimodal data. Bi is 2, so in this case, like Joe said, we have 2 spikes, okay? And so in this case, okay, this number and this number are going to give you something in the middle here, but that's not what the information really that's important is. What's important is, of course, looking at, you know, your spikes, in this case, where you have extreme attitudes. That makes sense to everybody? So the mode, okay, is going to be a better measure in that sense right there. Okay, so we talked about the mean, the median, the mode. Anybody have any questions? And hopefully you're filling out your worksheet as we're going along, okay? So I want to talk about 1 or 2 more things. I think I got a couple more things on measure the potential tendency there on the worksheet. One is the trim mean, okay? Anybody have any idea what a trim mean is? In fact, I don't even think this one is actually referred to in the textbook. But, trim mean, if I had Sarah's situation, where I had some extreme values, and I wanted to really kind of focus on the middle core part of my data, I might try to kind of get rid of some of the extreme values. If I did a 10% trim mean, which I think I noted, 10% trim mean, that would mean that I get rid of 10% of the highest values and 10% of the lowest values. So if I had 30 pieces of data, I'd throw out how much at the top and how much at the bottom. I'd throw out 3 pieces at the top and 3 pieces at the bottom. That would trim each end by 10, or 10%. So in our case, you'd wind up throwing out these guys, these 2 and 1 more. And then you would calculate the mean based on the remaining data. So a 10% trim mean I I would throw out 3 pieces in our case, 30 times, and then I'd calculate the mean. So how would we do that efficiently on our calculator? Well, let's go back up here, go back up to the top. And I don't want to really screw up all my data, so I'm going to go to list 2. Notice I'm above the bar. I'm going to go up to list 2, and I'm going to say, I want list 2 to equal list 1. So I'm just going to copy list 1 over there. So if I say list 2 equals list 1, and to do that, to put that formula, I've got to go up above the bar. And now I have list 2, which is a duplicate. So I don't mind messing with list 2 now. So let's delete the bottom 3 observations, which would be 61, 67, 70, so we've thrown them out. Now let's go to the bottom of the list, which is going to be the highest observation. And I want to throw out the bottom 3, which would be 97, 98, and 104. Delete, delete, delete. So how many pieces of data have we got left? 24, right? So we threw away 6 pieces of data. That make sense to everybody? All right, so somebody tell me the mean from those 24 pieces of data.
81.7.
Okay, so Kay said 81.7. I need a couple people to confirm that. That would be really good. Nick says yes, okay. Yes. 81.7 is the trimmed mean. That's pretty close to here. And that's an indication that we really didn't have to throw away a lot of data, because we didn't really have kind of extreme values here. That was pretty tightly packed. That makes sense to everybody? Had we had like some really wild data out here or out here, probably would be more important. But questions on how to get the trimmed mean. So all you did, I assume, is you sum them all up or take the mean of list 2, right? Questions? No? Okay. So if I trim mean, I need to do 2 more things with the mean. One of them is there. I didn't even put on the worksheet. I apologize. It's called the mean from grouped data. Mean from grouped data. Anybody have any idea what that means? It's a mean, it's an average, but it's from grouped data. Look, anybody have any clue what kind of interpretation? Yeah.
Doesn't mean boundaries or.
Yeah, so I think that's the right idea. It would be like not having the benefit of the data, but just having the benefit of the distribution, the picture. So if I only had this information, I wouldn't know that these 2 numbers over here are 61 and 67, because those are the 2 smallest observations. I mean, I know that because we work with the data, but if I didn't have the data and I just had the picture, and I didn't know I had a 61 and a 67 there, what would be my best guess for the 2 pieces of data that I do have in there?
76 and 82.
The midpoint, right? So if I didn't know what 2 pieces of data I had, I would assume they were both right at the midpoint. If I didn't know any better. That makes sense? And I would assume that these 8 pieces of data here we're all lined up right on the midpoint of this class, which would be 74, right? That's the midpoint of that class. Questions? Am I confusing anybody? How would I figure out the mean from the group data then? What would the formula look like then? Well, it would look like adding up 2 times 65. So it would be the midpoint times 2 pieces of data, right? And then what would I add to that next? I'd add 74 times the 8, I mean, it repeats itself 8 times. Questions? All right, then we're going to have what? 83, that must be the next midpoint, times 13, plus 92, times 4, plus 101, which is the last midpoint, times 3. And what am I going to divide it by? How many pieces of data have I accounted for? All 30 pieces of data, right? So 2, 8, 13, 4, and 3. Okay, so I would love to have that number. Somebody wants to give me that number. Everybody's starting to look at me like I'm a little goofy up here. 82 point what? 4? 82.4? 83. Joe, 82.4? So the group data is not too far off from the trim mean, and certainly this is the most accurate, 81.9. But the reason, again, is because I don't have, wild data. But that would be calculating the mean from the grouped data. Questions? Did you meet Galen? Good guy? Got a calculator? Okay, good. All right, so let's look at one more piece of information that I really